Let's refer to past year questions. Question number 12. Given gx equals to as follow, where x is not equals to 5 over 4, where k is a constant. A. Find the value of k if g composite with g, x equals to x. So in these questions here, what we're going to do is that based on the info, the composite function equals to x, we find out what is happened to be the k value. So what we're going to do the next later in our solution is that we begin with the calculations of g composite g equals to x as starting, and then we apply whichever knowledge we know about composite function, we substitute and simplify, and by right we should be able to find out what is our k value. So this is the idea that we're going to apply to solve this question. So as a result, our solution will begin, as I said just now, begin with the composite GG equals to X. And what we know about G composite G is that G composite G is actually happens to have the same idea as we substitute the function G inside G, or I should say in the way that I consider the part that I have X in the function G now. All the X now, I want to erase it. All the part that I highlighted in purple here, I would like to erase it and replace with Gx. And as the result, it will happen to be K multiplied Gx plus 8, 4 multiplied Gx minus 4. As we see, the K is being substituted as Gx. And then go on. We are not going to solve from this in the form of Gx here. So what we're going to do the next is that we can try to do substitutions of the Gx. So according to the question, the Gx is happens to be Kx plus 8 over 4x minus 5. So I substitute the Gx, and it is happen to be equal to x. However, in this form here, it will looks complicated, and at the same time, at this line here, I would like to simplify it, where it seems to be complicated when the time you see we have a smaller fraction inside a larger fraction. So how we're going to simplify it is that we want to get rid of the denominator of the smaller fraction by we multiply with some value, and this some value here we are multiplying is multiplied with 1. Where I want to emphasize this one here is because the result before and after, and why suddenly we can come up with multiply of something is because this value is 1. Before and after multiply of 1, each of the line, the value is always preserved, the value is maintained. And however, we're not going to multiply 1 in this form here because it's not really helpful. The one we will multiply is in the form of 4x minus 5 over 4x minus 5, so that we can get rid of the denominators. And therefore, what you happen to see now is that on top, we have k multiplied with kx plus 8, where you happen to see that when the time you multiply 4x minus 5 with this part here, it gives us k multiply kx plus 8. And by the time it multiplied with the constant 8, this is what we have. By using the similar idea for the denominator, this is what we have. 4 times kx plus 8 minus 5 times 4x minus 5. So again, by having 4x minus 5 at the bottom, multiply on these two terms here and get the result as follow. And don't forget, according to the question, they are equals to x. The next thing I would like to do here is that I would like to expand the terms here. I would like to expand the k inside. I would like to expand the 8 inside, the 4 and minus 5 inside. And then we try to find a way to do simplification. So when the time I expand the k inside, I have k squared x plus 8k. I expand 8 inside, I have plus 32x minus 40. Same idea, when the time I expand 4 inside, this is the result I have. And once again, don't forget, it is equals to x. Up to this line here, it still seems to be complicated. And what we're going to do the next is that I will suggest that we can do something like this. Let us gather the terms such that the x term we gather together for the one on top, and we happen to able to get the answer when the time we happen to gather and factorize them. I got k squared plus 32 multiplied with x, and then the constant term 8k minus 40. At the bottom, we do the same thing. We do the same thing. I gather the k together, and therefore I have 4k minus 20 multiply x, and then the constant 32 plus 25, I have 57, and this is equals to x, don't forget. Then we are almost there to get our answer. The next thing what we're going to do is that we would like to get rid of this denominator, where it's as if that we're going to bring this one multiply up on the other side, and this will give me the result as follow. So on the left hand side, it will remain with the numerator terms just now. On the right, it will be I'm having the denominator just now, this one in blue just now. I multiply with x. Now you shall see that the x become x squared, 57 become 57x. And by right up to this line here, we can start to consider to solve the k by comparing both sides. Compare in the sense of we try to compare the coefficients of the x of the same power, or I should say we compare the terms that alike. So before I continue with the compare, let's see what are the terms happen to be alike here so that you don't get confused. So when the time we look at the two sides for comparison, we find out that the term alike we have is the x term and also x terms. These are the two terms that alike. They are both referred to x, and by right I can compare to solve the k. However, this is not a good choice for finding k is because my k involve of square. If possible, we don't want to involve of square. As we know, if you solve square, it can give you more than one possible answer. We try to avoid that. We try to find something else in order to solve. But what else we can compare? You find out the remaining term, this one is constant. The other one is quadratic. So I cannot compare the constant with quadratic. However, you can have the idea like this in the next slide in red, where on the left-hand term here, we don't have the x squared term, but it as if like we have the x squared terms is actually come with the coefficients of 0. So now I can able to compare with the x squared term on the right. The similar idea, the right-hand side term, it doesn't have any constant written there, which means that it implies the constant is plus 0. So I can compare the constant term on the left-hand side. So these two will be a better choice to compare to solve the k value because they involve of k of a power of 1. And therefore, the next thing what we do is that we by comparing both sides. So when the time I say by comparing both sides, you just compare the part that you need for solving k. For example, what I do here is that I compare the constant term, which is the one that I highlighted in blue. This gives me 8k minus 40 equals to 0. And therefore, I can solve for the k equals to 5. And I don't have to bother about comparing the x squared term and x term anymore because the main purpose we compare is to solve k, and I already get the k. Even though you try to compare with the x squared term also is meaningless because it will only help you to solve k only. And of course, you can try to compare, and by right, they give you the same answer for the k value. So therefore, this is how we happen to solve for the questions of 12A for the past year in chapter 5.